Over several cycles, a refrigerator does 18,000 joules of work on the refrigerant. The refrigerant, in turn, removes 85,000 of joules by heat from the air inside the refrigerator. Part A. How much energy is transferred by heat from the refrigerator's inner compartment to the outside air? What is the net change in the internal energy of the refrigerant? What is the amount of work done on the air inside the refrigerator? What is the net change in internal energy of the air inside the refrigerator? Okay, step one, we're going to draw a picture. Okay, I'm not going to do a super amazing picture of a refrigerator. Instead, I'm just going to draw a couple of spaces. So this is our refrigerator. Anything in here is going to be inside the refrigerator. And then we have the refrigerant that goes between the spaces. And typically that is Freon. So I'm going to write that down. And then we've got the outside space around the refrigerator. So when we do a problem like this, we have to really think, what system are we talking about? Okay? And also, what is positive, what's negative, what's zero? Okay? So in part A, it asks, how much energy is transferred by heat from the refrigerator's inner compartment to the outside air? So we want the energy transferred by heat from the inner compartment to the outside air. So we're going to go from the inside and then eventually to the outside air. And we want to know how much heat. Well, what's going to take heat from the inside to the outside? Well, that is going to be the Freon. The Freon is what's going to do that. So my system is the Freon. Then we're going to go ahead and look at the first law of thermodynamics, which says the heat is equal to the amount of work plus the change in internal energy. And now I'm going to go back and read a little bit more and try to decide what might be positive, what might be negative, what might be zero. It says over several cycles, a refrigerator is going to do something. That means this is a cyclic process. And when something is cyclic, the change in internal energy is zero. Okay, so we have some information there. Well, what else do we know? It says a refrigerator does 18,000 joules of work on the refrigerant. Okay, so 18,000 joules of work is being done on the Freon. Okay, so that means the work is going to be negative because work is being done on the Freon. So negative 18,000 joules of work. Then we have to recall that this heat is the change in heat. So it's the heat that was added minus the heat that was removed. Okay? Read the next sentence. It says, the refrigerant in turn removes 85,000 joules by heat from the air inside the refrigerator. So 85,000 joules of heat is removed from the inside, which means it's going from the inside into the Freon. So it's maybe removed from the inside air, but it's being added to the Freon. Okay, so QH, the heat, this 85,000 joules is being added to the Freon. Okay, and our system here is the Freon, so this is going to be a positive. Now we can start substituting in. Let's substitute this in for the heat. So I'm going to have 85,000 joules minus the heat that is removed is equal to the work, negative 18,000 joules, plus the change in internal energy, which is 0. Solve this, subtract 85,000 from both sides, divide by -1. We get that the heat that was removed is 103,000 joules. Okay, let's go ahead and look at part B. Part B asks, what is the net change in the internal energy of the refrigerant? The refrigerant is the Freon. So our system is still the Freon. And that question is, what's the net change in the internal energy? So what's the change in the internal energy? Well, we answered this when we did part A. Okay? We said that the change in internal energy was 0 joules because it was a cyclic process. So we've already done that part. All right, let's look at letter C. Letter C says, what is the amount of work done on the air inside the refrigerant? Now, be careful here. What's the amount of work done on the air? Okay, the last two questions were about the refrigerant. Okay, this one is about the air. So we have a new system. So air, and it's the air that's inside the refrigerator. And the question asks, what's the amount of work? Okay, well, in this refrigerator, the refrigerator is a rigid container, which means that the amount of work that's done is going to be 0 joules. Okay, it's not going to expand or contract. It's an isovolumetric or an isochoric process on the air that is inside the refrigerator. Letter D asks us, what is the net change in the internal energy of the air inside the refrigerator? So again, the system is the air inside the refrigerator. And we want to know what's the net change in the internal energy. Okay, so let's go to the first law of thermodynamics. The amount of heat is equal to the work plus the change in internal energy. Well, in part C, we were using the system was the air inside as well. Okay, and there we found the work was 0 joules. So this is 0 joules, again, because we've got a rigid container. So that means the amount of heat is simply equal to the change in internal energy. Now, no heat is going to be added to the air. There's no heat coming in. The only thing that's happening is heat is leaving, okay? And it's leaving the air. It's being removed from the air. So that's negative. So negative 85,000 joules is equal to the change in internal energy. Okay, you'll notice the math for these problems is very simple, okay? It's a lot of determining what your system is and then looking at keywords and deciding if you have a rigid container, if work is being done on the system, if work is being done by the system, if heat is being added, or if heat is being removed. So it's a lot of vocabulary and a lot of interpretation from the question.